Hello everyone, I'm Mahathi with Global cli-MATES, and for today's episode in our Introductory Earth Science series, we'll be taking a step back and focus on the basics of scientific inquiry. A lot of the knowledge and concepts that we'll study in this course are based in scientific methods that have helped distill this information and make this information clear to people. So to start off, what is the purpose of science is a really important question that we should address, and in many cases, the goal of the natural sciences is to understand the world around us. And more than just understanding the world around us, it's also about, discovering the underlying patterns that drive the various phenomena that we observe, and also learning about, well, we know what has happened in the past, we understand these patterns, what can we expect to happen in the future? And through these processes of questioning, it allows us to gain deeper insights into how our world operates. And as we ask all these questions, we can see one of the biggest themes in scientific inquiry is the premise of first making observations about the world. What do we notice? What do we see? What are these facts and data we can collect? And then drawing conclusions from them that can potentially summarize or can at least describe part of what we notice. So you probably have heard of something called the scientific method. And maybe your experience with it is that the scientific method is concrete. It's unchanging. It's one fixed way of making new discoveries. However, in the real world, the scientific method isn't really something that's applied when conducting research. Instead, it might be better to call it methods of science, because there are often multiple different paths that can be taken when approaching a research problem. However, no matter what path people may take, there's often a few key components that are included. So we'll go over those key components today. So first, of course, are those observations that are first made. That leads to a question. So maybe we have a scientist that's outside that looks at a rock and is seeing that this rock has different colors and different splotches in it. And so questions, well, what are those different splotches? And how did this rock form so that we can see all these different splotches or minerals within that rock? And so this is kind of, the start of many research investigations. Additionally, as part of this, scientists typically create hypotheses. So hypotheses are predictions. A hypothesis or hypotheses, which is plural, are predictions about the phenomena. How did that come to be? So within the example of, well, how did this rock form with so many different types of minerals? Well, maybe the scientist makes a prediction. Perhaps this rock formed when magma or lava started to cool and form these big crystals. And then typically after this process of hypothesis and hypothesizing potential mechanisms of creation, there's often some testing and experimentation involved. And this is primarily to, as the name implies, to test the hypothesis and try and determine whether this hypothesis is accurate. And in a lot of cases, the testing isn't necessarily, done with, most of the times the testing is done with a hypothesis in mind, but in, for example, field studies, these tests are conducted just to get a better insights into how the world and how, the specific site in the field operates. And so one thing that I'd also like to mention here is when we say testing and experimentation, that doesn't just mean people mixing solutions together in a lab. If we think about, for example, astronomy, there's a lot of things we can't really do because we can't create our own stars or, fly a spaceship to a star, because stars are really far away, and, there's no practical way to do that yet. So a lot of testing done is also conducted through simulations and programs that have been built to model natural phenomena and are used to learn more about the objects we study, both in space and in some systems on Earth itself. So after we have kind of our testing and experimentation, we draw conclusions and share what we learn. Because one of the biggest and most important parts about the scientific methods is communication. Because you can, make all these discoveries, but if you don't share them, then that knowledge is not spread to the greater scientific community, which is why communication is super important within kind of this set of information. Now, I kind of presented this to you as like a chronological order where, well, we first have this, and then we have this, and then this and this. However, again, the scientific method is kind of an iterative process where steps are repeated again and again, and the order can be switched up in different ways depending on the nature of the experiment, the nature of the question. And oftentimes, there's a lot of repetition going between the hypotheses and observations, because in the testing, scientists make observations that, either disprove part of the hypothesis or disprove the hypothesis entirely. And so we go back to background research, learning about what scientists have already done in the past, and use that information to base new predictions or use your new observations to better understand and propose mechanisms behind the phenomena we observe. And this kind of brings me to one final point that I want to touch upon, is the concept of scientific theories and hypotheses. And so in everyday language, they're often used interchangeably, but when we talk about scientific theories and hypotheses, the terms are not interchangeable. So, maybe in your common day, people might say, oh, that's just a theory, I'm not 100% sure. And, maybe people don't necessarily use the word hypothesis, but, hypothesis and guess might be a word that you hear more often. Scientific theories are, they're kind of descriptions and mechanisms proposed about how the universe operates that have been extensively researched and extensively supported. Scientists don't call something a theory unless they have a lot of evidence, a lot of proof of something's existence and operation. Whereas hypothesis, as we mentioned earlier, is more of a prediction. It's not something that has been solidly proved. And so when people talk about theories in the scientific community, do not just dismiss it thinking, oh, it's just a theory. Scientific theories have a lot of proof behind them to back them up. Otherwise, they wouldn't be called a theory in the first place. And so as we kind of conclude today, I wanted to leave you all with a quote from the mathematician Jacob Bronowski. And as he says, "Science is a great many things, but in the end, they all return to this. Science is the acceptance of what works and the rejection of what does not." And so with that, I would like to conclude this lesson for today. I hope you all found it useful, and if you did, please like and subscribe, and comment down below if you have any questions or suggestions for future content. Thank you all for watching. Bye!